Now something else which is relevant from a security point of view, if you say show run include enable and user, I have configured both the user and the enable password using the password keyword. So the password of the user is configured using the password keyword. Likewise, the enable password is configured using the password keyword, which means the password is visible in clear text in the show in the running config, which that's very easily for somebody to use the shoulder watching method to quickly see, oh, this is the username and password I need to know in order to connect to the router. So likewise, if you want to copy the configuration file of the router between, for example, router 3 and a remote FTP server, if you want to copy that configuration file, if somebody in the transit path gets their hands on a copy of the transfer, is going to be able to see in clear text the passwords that are required to get access to the router. So what you can do is, one easy way, if you have the passwords configured using the password keyword, you can say in here on the router service password encryption. That's a global command. Service password encryption. And if you say now again do show run include enable user, you're going to see that those commands are now being hidden. So there you go, the password no longer shows up in clear text for the user and also for the enabled password. But what you see in here, in show run, you see in here this 7, which is a type 7 encryption of the password, which is actually just which is a very weak algorithm proprietary by CISCO, which is easily reversible and breakable. So if now somebody actually takes a note of this hashed password or protected password, it can actually very easily identify what is the clear text password by looking up on the internet for things like let's do it real fast. If I want to take this one, so I have two options to decrypt that password, to call it that way. We can put in here, let's say Cisco type 7 decryptor, decrypt. You click on the first URL, you put in the hash value, you say submit, and you end up with the clear text password, which was enabled 15. So you can either do it online or using any of the security tools, or of course you can do it even on the router by creating a keychain and saying keychain test key 1, and then you say key string, and you say that I'm going to paste in a type 7 password, so not the clear text password, so this one. And then if you say show keychain, you're going to find out the clear text password. There we go. So ideally what you should do, you should never ever use the password keyword to define the enabled password or the user's password. You should use the secret option. So you should go in here and you say, let's remove this, no this, and you say username local privilege, let's say 10, with the secret of local. So you define the password by using the secret keyword. Likewise, you remove the enable password and you say enable secret, enable 15. Now if you say show run again, include username and enabled, you're going to see now that the password shows up a bit different. Now, what this means, that the type of the encryption, if you want to call it that way, although it's not encryption, is type 5 now, which means that the password is stored in the running configuration file as an MD5 hash, which this is technically, we're going to speak more in details tomorrow in encryption and in the cryptology algorithms, that the MD5, any hashing algorithm, is technically speaking irreversible. We're going to see tomorrow when we speak in more details that the main characteristic of a hashing algorithm is that, technically speaking, if it doesn't have any vulnerabilities, which all of them have, especially the collision vulnerability, either it's a long discussion. In most cases, let's say that the MD5 hash algorithm, like any other hashing algorithms, are irreversible. So they state something like the hashing algorithms is like you have an orange, you put it in the blender and you make orange juice, and then from the orange juice you cannot make back the orange. So that's real life facts. However, from the technical point of view, because of a lot of, let's say, vulnerabilities and a lot of attacks, actually hashing algorithms are irreversible in certain cases. So to map that concept of the orange and orange juice, it means that once I have from the password, once that from the clear text password of, let's say, enable 15, I have computed the MD5 hash, which the MD5 hash is this one. It means that from having the MD5 hash, I can technically never ever identify what is the clear text password. Now, unfortunately, if the enabled password uses a weak password, it is still breakable if you use what I've told you the other couple of days, the Kali Linux distribution. They have special tools to break passwords which are stored as MD5 hashes, especially if the passwords are weak. Now, the way the MD5 hash is computed to be more secure is as follows. So I have my clear text password, which was enable 15. I have the algorithm, which is MD5. And for the router to end up with that specific hash, so the router takes the clear text password of enable 15 and puts that in the MD5 hash engine as an input. It takes the clear text password, puts that in the MD5 hash engine, and also it adds a random value. So as you type in the enable secret command or the username something secret command, at that moment the router generates a random input, random data, and it puts in the MD5 hash engine both the random data and the clear text password, and the result is the MD5 hash, which the MD5 hash is what you see in the running configuration, which is basically this. Now, clearly you can imagine that, well, if the router generates at that specific point in time a random value, and is going to put that value alongside with the password in the MD5 hash engine, and the router never actually remembers that random value, then how can authentication work? Because then when I'm connecting to the router and authenticating locally, and I'm putting my password in a telnet session, then the router has to again, so like for example, what I'm trying to say is the following. If I telnet now again and I want to authenticate with the username of local, For the router to allow me to get in successfully, I have to provide to the router the proper password. But then what's going to happen is the router has to put in the MD5 hash engine, MD5 engine, has to put in here the password that the user types in at the telnet session, and the same random value that was used initially to compute the hash of the user's passwords. Because in the end, those two will end up in the MD5 hash. And for the user to be authenticated, that MD5 hash has to be identical with the hash from the configuration file. So the question is, how does the router know what was the random value used initially to compute the MD5 hash, so that it's going to be able to put that again in the engine to authenticate users as they show up? And the answer lies within the MD5 hash format. If you look it up in the ensure run, the first portion of the MD5 hash is $1. Now, dollar is a separator. What $1 means is that the password is protected using type 1 protection, which means via MD5 hashing. But then you might say, oh, but the type 5 already specifies that this is a MD5 hash resulting password. Yes, but basically this is the CISCO's MD5 algorithm, because nobody knows exactly. So what's going to happen is that the way the hash is computed, the router takes in that random data and the user's passwords and puts those in the MD5 hash engine, but the algorithm is pretty much undocumented. How does it exactly work? So that 5 number in there identifies this is as a result as an MD5 computation, but this number, this $1 keyword in here, tells the CISCO that I'm actually using method 1 of MD5 hashing. And then what follows next after $1, it is $KO \R. So $KO \R. What this means is that KO \R was that random data which was initially generated by the router to compute the MD5 hash of the password. And then what follows up after that data, which is $VE whatever, what follows the $sign, so $VE whatever, then this is the actual MD5 hash of the password. So this is how the password, the MD5 hash, is being generated, and this is how the router knows what was the initial random data which was used to pre-compute the MD5 hash initially when the administrator has typed in the command enable secret or username local secret whatever. And as you can see, the random data between the enable secret and the user secret is different, because that's for real random. Like for the enable secret, the random data is KO \R, while for the user local secret, random data is MGOE. So that is for real random. So ideally, this is what we should be using, the secret option, not the password option.